Today we are going to see the operator method of solving harmonic oscillator problem. I have given this lecture long back, but which is of poor audio quality. In this lecture, not only I have improved the audio quality, I have improved the content also. We will see some interesting phenomena about the harmonic oscillator problem. The Hamiltonian for the harmonic oscillator is equal to p squared over 2m plus 1 over 2 kx squared. So if you see the first term and the second term, both are symmetrical. So it is a parabolic one. We know that the angular frequency is defined by square root of k by m. If you substitute this for k, you will get h is equal to p squared over 2m plus 1 over 2 m omega squared x squared, because k is equal to omega squared into m. So this will become m into omega squared. Of course, here you have x squared. Here, what I am going to do is I am going to multiply and divide by h cross omega. So I am multiplying the by h cross omega and dividing the both term by h cross omega. You can see here. So I have divided it by h cross omega here as well as here. It is very interesting to note that just because I am dividing with the first and second term by h cross omega, you can see here the omega and omega squared will get cancelled. So you will get m omega x squared, and we are going to rearrange this. That is, I am going to write this p squared over 2m h cross omega plus 1 over. I am bringing this m omega in the numerator of this numerator. So I have rewritten this as h cross omega p squared over 2m h cross omega plus 1 over 2 h cross divided by m omega into x squared. There is some meaning why we are doing like this. We will see what is that. We arrived at the Hamiltonian part, the harmonic oscillator is h cross omega into p squared over 2m h cross omega plus 1 over 2 h cross divided by m omega x squared. Here I like to highlight some interesting and important phenomena that just you ignore 2 time being, you ignore 2 because it's a constant. The dimension of m h cross omega is equal to the dimension of momentum squared, which is in the numerator. So momentum squared divided by momentum squared, this will become a dimensionless quantity. Interestingly, here in the second term, h cross divided by m omega, uh, the dimension of h cross divided by m omega is length square. Here you have x square, length square. So the dimension of the second term also dimensionless. Second term also dimensionless quantity. So what I am going to do is I am going to keep small p squared over 2m h cross omega as capital P squared. Similarly, 1 over 2 h cross divided by m omega multiplied with the small x squared. I am going to keep this as a capital X squared. We know very well the u squared plus v squared is equal to u plus iv into u minus iv. Here x is a real term, so I am going to keep the imaginary part to p. You know very well the momentum operator is minus I h cross delta. So nothing wrong in using uh, x as an imaginary value also. It will not affect your result or alter your result. It is a convention to keep the imaginary part for momentum operator. So this will become, you can rewrite this as h cross omega x plus ip into x minus ip. Here, capital X is equal to 1 over square root of 2 h cross divided by m omega x. I am taking square root because this is x squared, so x will become small x, capital X will become this. Similarly, capital P, this is capital P squared. Capital P, you have to take square root of the first term, which is equal to P divided by square root of 2 m h cross omega. So we got the Hamiltonian, which is equal to h cross omega into capital X plus IP into capital X minus I capital P. So here the red color band, the parameter I have shown in red color band, that is X plus capital X plus I capital P is taken as A, operator A. This is called annihilation operator. We are going to see why it is called annihilation operator in a couple of minutes. So you know this is the X. First term is X. Second IP, you know this is the P, capital P. P divided by square root of 2 h cross m omega. Similarly, the another operator which is called a dagger, this is the creation operator. We are going to see why it is called creation operator. I have taken this red color font, x minus ip, both capital. You know, capital X is equal to small x divided by square root of 2 h cross divided by m omega, and capital P is equal to P divided by square root of 2 h cross m omega. Of course, here one I is there. So we will see what will happen to this expression. So we have seen A is equal to capital X plus I capital P. Capital X can be written as X divided by 2 square root of 2 h cross divided by m omega. Similarly, the P, capital P, I have written in terms of small p, which is equal to P divided by 2 m h cross omega. Of course, you have I. Similarly, A dagger, this plus will become minus here. So now we will see another interesting thing, that is we will see the commutation relation of A with A dagger. A dagger is equal to A commutation relation with A dagger is equal to A dagger minus A dagger A. First, we will see what is A dagger. That is, you are going to multiply this and this. If you multiply this and the operator A and A dagger, X will commute to X. So you can ignore the X value. So you concentrate only on the cross term. Here the cross term is, you can see very well, everywhere there is a 2H cross. Yeah, everywhere 2H cross, 2H cross. Here also 2H cross, here also 2H cross. You keep it in mind. Everywhere, in all the term, you have square root of 2H cross. So square root of 2H cross. If you multiply A and A dagger, you can multiply the cross term because X will come into with X, P will come into with P. So now you multiply X and P. So X, if you multiply with this P, the second term, you will get IXP. You are not supposed to change the order of the operator. That I have explained many times. So here one minus. So minus will become here minus I, because here you have IX into P, and you know that this m omega, numerator m omega, this is square root of m omega, denominator m omega will cancel with this numerator m omega. So you will left with only square root of 2h cross, here one square root of 2h cross, which will become 2h cross only. So next you multiply the second term with this first term. Here you can see m omega in the numerator, square root of m omega. Here you can see square root of m omega. Both will get cancelled. You will get here square root of 2h cross, here square root of 2h cross. So here also plus plus. So you will get I here. What I is there? IPX divided by 2h cross, because here you have square root of 2h cross, here one square root of 2h cross. So if you multiply both, you will get to 2h cross here. Similarly, if you multiply this is minus a dagger here, that is you are multiplying this with this. Same thing applicable here also, because x will come in with x, p will come in with p. You have to take only the cross term. So here cross term is you take first x and multiply with p. Remember that you are not supposed to change the order of the operator. X is an operator, so x, this will become on I x p. So with the same logic, because in the denominator you have square root of m omega, here in the numerator you have square root of m omega, which will get cancelled. So you will get here one square root of 2h cross, here one square root of 2h cross, which will become 2h cross. Similarly, if you multiply minus ip with x, so you will get minus ip x divided by 2h cross in the same manner. So what I am going to do is, in the numerator, all the term you have I. So I have taken I. In the denominator, everywhere you have 2h cross. So I am taking out the 2h cross. So this will become uh, px. I am taking second term first. Px minus xp. Here you will have xp minus px. This is the final version. Now, this red color bond which I have shown is px minus xp. That is commutation of p with the x, which is equal to minus ih cross. So this is equal to minus ih cross. Similarly, xp minus px, which is nothing but x commutation with p. X commit, if x commit with p, you will get plus ih cross. Already there is one minus here, so I have taken that as minus ih cross. So you remember that here one I, here you have I everywhere. So you take I outside. I into I will become I squared, which is minus 1. Here also minus 1, minus minus. So all minus will become plus. So this will become 1 over 2 h cross. Here you will get h cross plus h cross, which is nothing but 2 h cross. So which will cancel. This 2 h cross will cancel with this 2 h cross. So this will become 1. That is commutation of A with A dagger is equal to 1. We have seen that the annihilation operator A is equal to capital X plus IP. Similarly, the creation operator A dagger is equal to capital X minus I capital P. Now, if you add these two, that is A plus A dagger, this P will get cancelled, you will get 2x. Or x is equal to 1 over 2 A plus A dagger. In similar way, you will get P is equal to, that is after subtracting A minus A dagger, you will get P is equal to 1 over 2i A minus A dagger. So now you got the value for capital X and capital P. Now if you square the capital X, that is capital X squared is equal to, this will become 1 over 4, and A plus A dagger whole squared will become A squared plus A dagger squared. And you keep it in your mind that A will not commit with the A dagger. So this will become A dagger A dagger plus A dagger A. Similarly, what about P, capital P square? So this will become 1 over 2 I whole squared. I squared is minus 1. So this will become minus 1 over 4 uh, into A squared. That is uh, annihilation operator. A squared plus A dagger squared. Since A dagger will not come in, this will be equal to minus A dagger minus A dagger A. This is now if you add to x squared, this one and this one, x squared, capital X squared plus p squared, you can see that both in both term you have 1 over 4. Here you remember 1 over 4, of course, with the negative sign. So the first term will get, sorry, 1 minute. The first term will get cancelled with the first term, and the second term will get cancelled with this second term. Now you can add third and fourth term. This will become 2 a dagger, because here a dagger, here it is minus, and here one minus, minus of minus will become plus. So a dagger plus a dagger will become 2 a dagger. Similarly, the fourth term, a dagger a plus, because here one minus you have, so minus of minus will become plus. So this will become a dagger A plus A dagger A, that is 2 A dagger A. If you take 2 outside, 2 by 4 will become 1 by 2. So now you can see the green color bond, that is A dagger A. A dagger A is called number operator, N. We will see in a couple of minutes why it is called number operator. Then what about A dagger? We know the commutation relation. Yeah, commutation relation of A with A dagger is equal to 1. We have seen it. So commutation of A dagger is nothing but A dagger minus A dagger A, which is equal to 1. So the first term will become as it is A dagger. But we know A dagger A is N. A dagger A is N. That's what I have written. So you take the n to the right hand side. So this minus n will become plus n. So this n will become, right hand side will become n plus 1. So what will happen is this n plus 1, that is a dagger is equal to n plus 1, according to this relation which I have shown in the red color rectangular box. A dagger is equal to n plus 1. So I have shown it in the green color bond. N plus 1, this is n. So which is equal to 2n plus 1. So you can see the outside the bracket, there is 1 over 2. So if you bring it into inside the bracket, you will get 2 will get cancelled. This will become n plus of 1 over 2 of. So if you add capital X squared plus capital P squared, you will get n plus of. We have seen that the capital X squared plus capital P squared is equal to n plus of. Uh, and also we know that the Hamiltonian for the harmonic oscillator is equal to h cross omega plus into capital P squared plus capital X squared. We know that p squared plus x squared, capital P squared plus x squared is equal to n by n plus half, this one. So this is n by half. We know it's a well established relation that Hamiltonian for a harmonic oscillator is equal to h cross omega into small n plus half. Hence n is called a number operator. Small n represent the energy state. That is, for zeroth state, it is H cross omega pi 2. Over first state, it will go Asan. This is a number operator which is justified. We know very well that this is the well-established relation that Hamiltonian for a harmonic oscillator is H cross omega into n plus half. Now we will see about the creation and annihilation operator. Before going to the creation and annihilation operator, we will see the commutation relation of creation, annihilation and the creation operator with respect to the number operator n. First, we will see the commutation relation of n with a. So you know very well n is a dagger a. So this can be written as a dagger a commit with a. According to commutation relation, this can be written as a dagger a comma a commutation, and plus this a dagger comes first, and a this a will come to right hand side. This a dagger will come to left hand side. Because we are not supposed to change the order of the operator, because here a and a daggers are operator. And also it is well known fact that a will commit with itself, that is a will commit with a, so this will first term will become 0, and a dagger a, we know a dagger is plus 1. So a dagger a is equal to minus 1. This will become minus, here one a is there. So this will become minus a. So in turn, the commutation of n with a will become minus a. In similar manner, the commutation of number operator n with a dagger is equal to a dagger a with a dagger. So this a dagger will come to left hand side, and this a dagger. Similarly, this a will come to right hand side according to commutation relation. Then there is a dagger, here one a dagger. As in the previous case, this a dagger will commit with a dagger, so this will become 0, and a dagger is plus 1, so this will become a dagger. So the commutation of n with a dagger is equal to a dagger. Now we will see about the creation operator. That is we, just now we have seen that the commutation between n and a dagger is equal to a dagger. You know very well that n commit with a dagger, you will get n a dagger minus a dagger n, which is equal to a dagger. This is the relation. Now you bring this second term to the right hand side, this term to the right hand side, so you will get a dagger n. A dagger n plus already there is an a dagger. Now you can take a dagger out. So this will become a dagger into n plus 1. This is a number operator. You can bring left or right. That is not a problem. It will not change your result. Suppose if n is an operator on get n, then capital N act on get n is equal to small n get n. So now you bring this, use this relation, that is n a dagger. N a dagger is equal to a dagger n plus 1. As I said, n is a number operator. You can use it in the right hand side or left hand side of a dagger. Only if it is a, you are not supposed to interchange. So this will become n plus 1 a dagger. When n plus 1 act on get n, you will get small n plus 1. Number operator act on n, you will get n, small n plus 1. Of course, here you have a dagger which act on n. So when creation operator act on n, it will increase the energy state by 1. That is, n will become, here you can see n will become n plus 1. Here n get n is equal to small n get n. Capital N, a dagger get n will become n plus 1 a dagger n. That means when a dagger creation operator act on get n, you will get energy level n plus 1. Now we will see about the annihilation operator. Just 2 minutes back, we have seen the commutation relation between the number operator and the annihilation operator, which is equal to minus a. If n commute with a, you will get na minus an. As usual, you take the second term to the right hand side, you will get an minus here on an minus a, which is equal to, you can take a outside, which will become n, capital N minus 1. Same logic, if you apply the same logic which is applied to creation operator, if n is an operator on get n, then n act on get n, you will get an eigenvalue n get n. If the annihilation operator operate on get n, that is n a n. You know n a is equal to a n minus 1. As I said in the previous case, n minus 1 is a number operator, so you can bring right side or left side, nothing will change. So I have taken this a n minus 1 as n minus 1 a. So when annihilation operator act on the get n, you will get uh, the n minus 1 a n. So n minus 1 act on the get n, you will get to small n minus 1. So when annihilation operator act on get n, the energy state is energy level is reduced by 1. That is, when a act on n, you will get nth state will become n minus 1th state. Our next task is to find the expansion coefficient naturally, because the expansion coefficient gives you the probability. So the n plus 1th state can be written as a dagger n, because when a dagger act on nth state, it will rise the state level by 1, n plus 1. Of course, with expansion coefficient Cn, that is probability amplitude Cn. Now you take a inner product on n plus 1 left hand side and as well as right hand side. So when you take inner product, this is a number. Cn can be taken as a Cn modulus square, and this will become, when a, you remember that this is bra vector. So bra vector, when a operate on bra vector, this will become naturally a dagger complex. This. Uh, when it act on the Prague vector, naturally this will become n plus 1. This a dagger also will become, a dagger n also will become n plus 1. So both right hand side and left hand side are same. Because when a act on a Prague vector, this will become n plus 1. So and also, you know, a dagger, just now we have seen, is a dagger is equal to capital N plus 1. When capital N plus 1 act on this get n, you will get energy state of n plus 1. So you can take this n plus 1 outside. So you will get n inner product of n with n. So according to orthonormal property, this will become 1. Similarly, in the right hand side, due to orthonormal property, the inner product of n plus 1 with n plus 1 will become 1. So this is equal to 1. So naturally, then naturally Cn, Cn will become, you can bring this n plus 1 in the left hand side. So since you are taking square root, Cn will become 1 over square root of n plus 1. So this is the Cn value. If you substitute this Cn value in the first equation, that is, you substitute this here. Here you have Cn value. If you substitute here, what will happen? This Cn is replaced by 1 over square root of n plus 1. Of course, this A dagger will come as it is and n will become as it is. So if you bring this square root of n plus 1 to the left hand side, you will get A dagger n is equal to square root of n plus 1 uh, uh, multiplied with the get vector n plus 1, because here n plus 1. So if you bring this square root of n plus 1, you will get A dagger n is equal to square root of n plus 1 into the get vector n plus 1. If you see some interesting phenomena here, when n equal to 0, then uh, this A dagger, when creation operator act on ground state, that is n equal to 0, this is 0 plus 1 1, so 1 square root of 1 is 1, here n equal to 0, so it will rise its level by 1, so ground state will become first state, that is A dagger get 0 will become get 1. So it will keep on going. If you take 1, it will become 2. If you take 2, it will become 3. Likewise, it will be increasing by level 1. Similarly, the get n minus 1 can be written as Cn A n. A is the annihilation operator. So when A acts on n, you will get n minus 1. Just as previous case, you take a inner product of n minus 1 with n minus 1, which gives you 1. Similarly, in the right hand side, here A, when you take into pra vector, it will become A dagger. So this is the complex vector. Pra vector is a complex vector. So this will become A dagger will become A when act on the pra vector. This will become n minus 1. This is also n minus 1. So here A dagger A is n, we know very well. So n is a number you can take. When n act on get n, you will get eigenvalue of n, small n. So this will become Cn modulus squared n into n inner product of n with the n, which is equal to 1. So this Cn modulus squared will become 1 over n if you bring this n into the left hand side. That means Cn is equal to 1 over square root of n. Now you substitute the value of Cn here. You substitute value of Cn here. So what will happen if you substitute here? Then the Cn will become 1 over square root of n A into get n. If you bring this square root of n to the right hand side, you will get A get n is equal to square root of n get n minus 1. Here, one interesting phenomena. In the case of creation operator, we have seen that when n is 0, it will move to n1. If n is 1, it will go to 2, and like that, it will go up to infinite. Even if n equal to 0, it will go to next level for creation operator. However, for annihilation operator, if n is equal to 0, you can see this square root of 0 is 0. 0 multiplied with get vector is going to be 0. That means you cannot go lower than the ground state energy. This is the very, very important result. This is about the operator method of dealing with the harmonic oscillator problem. In my next lecture, we will see some of the problem which will be solved using the operator method, that is using annihilation and creation operator. Thank you very much for watching my video and supporting me continuously. Thank you.